Hello everybody and welcome to this tutorial, how to model a functional utility knife with Shapr3D. In this process lecture, I will show you all the individual steps I took, starting with exploring the initial form and how to sketch it, and then modeling outer and interior details to produce a functional utility knife ready for testing and manufacturing. Please feel free to download the shared file so you can follow this demonstration better and explore the design on your own. Great. Now let's get started. Very good. So here we are. Let's take a look at what we have. On the left side, you see there are 1, 2, 3, and 4 models. And these are actually representing the initial exploration of the basic form. And then on the right side, we have 5 individual steps. For example, there I start shaping the details more, then starting to core it out, add, for example, threading and a hinge. Then I am planning on adding the blade. And then in the end, I will also have all the elements to hold the blade and the blades inside in the handle. So let's take a look at how I started first. The whole design, in addition, is also sorted into the start and the detailed models. There is a blade object, and here inside this folder are all the sketches. So let's turn all this off, and let's take a look at the sketch. This exercise is based on a very old utility knife. It's metal cast, it's very organic, and it surprisingly works really well. The way how it is in your hand is nice and comfortable. You can work with this for a long time without getting a fatigue in your hand. Because it is nice and organic, I assumed, well, we can quickly retrace this out of arcs. So this is what I tried to do here. There you can see I put in all the arcs, but I quickly noticed that while it is possible to create a sketch with this flow, it is also somewhat a little bit labor intensive. And I always try to make sketches as simplistic as possible, simply to allow me to work faster and have less work. What I also noticed based on the sketch, when I created a revolve object, I started to have these edges actually on the surface, which I didn't really want. Plus, because this is an arc, this area was a little bit too, let's say, linear. While it is rounded, it's just not round enough. So to improve this, what I did, let me go into 3D view. I took the sketch and then made actually a copy of it and moved it to there. So into the background. So when I then went back to the left view, I could very easily start tracing over it. So here is a new sketch. 1, 2, 3, 4, 5 points. I'm using the fit point spline. The nice thing about the fit point spline is that it creates very smooth and fluid shapes. You can also see here how, for example, the fit point spline is a little bit more bent. Ideally, that is what I wanted. The trick of the fit point spline is we need to figure out where we have to position all these points to exactly get kind of like the type of a flow we're looking for. But this was only a matter of pulling these points. And then when we take a look at this shape, which I then revolved, there you can see, compared to the circle one, this is nice and smooth. Okay, so this was kind of like step 1. This is also a process I very often teach my students in industrial design. When you learn CAD, try to think about how would we do something in a model making shop. So we could take foam and put this on a lathe. And then later we take a knife and start cutting more elements away from it. So that is actually now the step that's happening here. So this is the initial sketch here again. And I drew a line and there and added more lines to it. So I could create these 2 or 3 fill areas. And those I used to actually trim everything. So for example, for those who are not familiar with it here, I'm just quickly rebuilding this there. And there we are. This is all selected. And then we can cut this away. Cut this away that way. And then this we delete. And there we are. Super easy, no? Nice. Okay. So this was actually from the site. But when we take a look at here, you also see that we have these sides being cut. So this is actually not just from the top something that's cut down or strictly from the side. As you can see here, this is a cube where one side, so meaning this face, is actually rotated. So how did I do this? Also here, very simple. And also Shapr's direct modeling tools are really fantastic for it. So I brought this over 200 millimeters. I actually moved all those in 200 millimeter steps. This is, while what I show you here, well, it's modeled actually in steps. This is also how I internally work when I explore variations. It's actually just easier to spread something out. And then it's kind of like a manufacturing street where we do particular tasks. So as you saw, I can always make a new copy, bring it to here, and then redo something. So this shape, I actually extrude a little bit, and you see how it cuts into the body there. That's not good. Let's make a new body. Now, this face is the problem. We have to rotate it, and this is super easy. So select the face, then the widget we move to there, and let's rotate it. Now we need to pay attention to is how well actually does this intersect. Is this good? 13, 11. Yeah, this is good. Very nice. So one part is done. Can make a copy by simply mirroring this over. I use here a sketch. And there we are. And then from this, these two I will subtract. Very good. And there. See, super easy. Okay. So based on how I sculpted this object and based on how here these lines are drawn, I can then create all these angled faces. Very good. Everything is nice and round, and the top surface here I would like to be round too. So the way how I did that was then that this I brought over. And you can see here there is a line. The line is actually a copy here from the sketch. I brought this one over, and directly onto this line I would like to add a sketch that is kind of like running along, so perpendicular to it. And use a construction plane. So we don't want to just draw a sketch, this one, and then simply try to rotate it into position. We do it differently. So we go to add construction plane. And then here we have various options. So through edge at an angle, perpendicular to curve, perpendicular to edge. There. And then we can drag this to where we want. And you see how this is actually at an angle. When I select this plane with a finger double tap, and then quickly draw something, and we can see how this is now perpendicular to this line. So that is the way how I created this. Very good. So this shape, then I can make this new, and might have to hide this, push this back. And this arc is now going to kind of give a shape to the top part. So from this, I would like to remove this. And there we are. Super nice. Okay. And at this point now, we're actually making a transition from exploring the basic shape, going into the more refined details. In this step here, you can see I have the corners rounded. I also have a material thickness, and it's colored out. This task of giving a wall thickness is something you want to do after we rounded the outside. So this one here, let's move over. I think in this case it was 100. Yep, correct. Here we have various edges. We can select them all at the same time and then round. And you see how I get this triangular edge. Or I pre-round one edge, this one, and then select those edges and round them. You see how I'm getting a much nicer flow. And while your hand sits on this surface, this is then something where your thumb actually could rest on. It's nice and comfortable. Okay. Now, because this edge is rounded, if I now select this face and then go to shell, 2 millimeters, and go to left and turn on the section view, there you see how you also end up with a nice rounded interior edge. Very good. See, that's actually that easy. It's not really complicated. And because this is going to be a symmetrical object, I also have here a square at the bottom, and I just extrude this up and create myself half of an object. Very good. Okay. Now let me go back. Okay. I will go back one time. I made a tiny mistake. I forgot actually the rounded corner at the bottom. That's actually no problem. We have this here. So revolve. Very good. And now this we bring over. Again, you see how it perfectly snaps in. One of the main reasons why you want to work with the grid. I made kind of like a mistake, but it wasn't really a problem to clean this up. So maybe it was good I made this mistake. Showed you how good direct modeling is. Okay, so there seems to be another object there. So let's see. This is 1, 2, and 3. These were the old parts. Okay, very good. So, and then this here, 2 millimeters. Very nice. Okay. Fantastic. Okay. The whole process of designing, and sometimes people are scared away by the complexity. It's actually not really that complicated. When you take the amount of details here and think about each detail as a small problem. And we have to figure out when ideally do we work on a sub-problem. It's kind of like a house of cards. We put one card to the next, to the next, to the next, and then later have a construction. So that's the same way how you want to approach 3D modeling too. It's very logical. The next step after we did this shelling is maybe to think about when we have two sides that can rotate, where is the axis going to be? So this whole part, let's move over. And let's take a look at what I have there first. Here's a line. I drew this line from the side, so I can figure out actually where is the center. And then at the center, I created this circle. Now this circle was very useful because when you create a circle, I'm going to move this circle to somewhere else. And you select the outer face, then we can create an axis through it. And along the axis, we can create a plane. So currently here we don't see it. So what you want to do is add and construction plane. And then here we say through edge at an angle. That is the correct one. It doesn't really matter the orientation. There we are. Very good. And then on this plane, with your finger, if you double tap, we can start drawing more elements. And you see how this then snaps actually or projects the axis into the sketch as a line. So let me delete all those and this, because this is basically how I created these two shapes. I wanted them to perfectly rotate and stay inside this circle. That's also why I have this axis or the sketch. That's my revolve axis. So what are actually these two elements? So the inner one, I will revolve around this part, and then from this, I will remove this one. There. So this actually created an opening. And then this, around this line, I will revolve. Very nice. And this I can try to move forward a little bit. And we see how it sticks through. So these two I will join via union. Very good. And then there's kind of like this opening. That's not good. Welcome to direct modeling in Shapr. We simply move this face and close that opening. Done. Beautiful. Now we can do a very quick test. So if we select this and mirror it along this face, there is this part. Very nice. This is good. And this one, if I move my 3D widget to there might be some sort of a hinge inside. Okay, there we can rotate it. Very good. Okay. Prototyping 101. So the axis kind of like we figured out. I also previously put a blade to there, so I understand where roughly this axis only can be, so it's not actually intersecting with the blade. And let's take a look at the bottom here. So there we actually have all those details. So the bottom element, I actually split one time. Let me show you how I did this. So I do and move forward and backwards to make a copy. Now I have to move this back -1. Very good. And then I will hide this one. Down here, I have quite a lot of sketch elements. I think this should probably do it. Very good. Yep. And I will revolve this. Very good. So from this, I will remove this. Keep the modified body. Okay. Let's remove this. There we are. Pretty cool. So you see that actually this way I sliced this one. Now I just noticed that there was a little bit of a dirty element left over. Not a big deal. I do a new revolve. Expand this a little bit. Bring this one down. You see it snaps together. Expand this more. Very good. So this I need. This I can hide. This is not wide enough. Very good. So double tap, intersect. There is the bottom part. So that's actually how easy it was to create kind of like a split of these two objects. Let's take a look at my final design, and I will give me 1 second. I will hide the threading there because there's actually a little bit more going on. You see, when I select this, I have a new element there. Because this is actually, how could I say that? Something I needed to add because the cap later will be rotated or threaded onto it. So let me show you how I did this. Again, this is really, I hope you see how logical all these steps are. To overbuild a little bit, I expand this a tick. Very good. And now I noticed actually that this needs to be to there. Okay. So this I will hide, and then you two join together because this was revolved 360 degrees. I just remove a little bit. So the other element is a tick longer. So what do we do? That's actually very easy. From this, simply remove this one and keep my tool there. So this was now made shorter. Easy as pie. Pretty cool. Let's go back to details. They also notice, there is a triangular element there. So when I want to add threading later, there's a video about how to make threadings. So I won't go into detail here too much. I need the threading to sit on something. So I need to give a little bit more material to here. So let's revolve this. Can actually just revolve 180 that way, and then These two we join, so I don't have to trim from the bottom via extrude. Okay, let's take a look at the detailed part. There we are. And here is a triangle. And there's a triangle. So this is how I started blocking out the threading. But if I do a threading, there's literally no air in between. So I offset actually some of these lines so I can create smaller triangles. So then this triangular profile I select this line, then I go revolve, and then the trick here is that we move this one down. Very good. Okay, 360 multiplied by 2 is 720. Let's move this by 4 millimeters. And you see how easy it is to take 1 turn, 2 turns, 3 turns. So this would be another 60, so 80, another 300, so 1080. And this has to be then 6 millimeters. Ta-da! Okay, and then we do exactly the same for the outside. So that is the way how I build the threading, and then the inside we can shrink a little bit so it overlaps with this body more, and then we can join those better together. It's called overbuilding. It's a practice I use a lot. So I don't have one face sitting on another face. I have more volumes intersecting with each other. Then we kind of like finished the threading. We finished the axis. That is all good. The next step then is, well, the blade. How do we get the blade? Also not complicated. I will actually go back just to this model. And here is my blade. I make a copy. Just move this over. And then rotate it as I would like to. And I lined this one up with the top and bottom edge. And this is basically the way how I brought this into position. Very good. Let me hide this. And then there you see all these projections. These came from the individual elements of the blade. So I projected this project into the sketch, and I simply tapped the grid that projected it right onto the sketch. Let's hide those elements. There is this body, and I move this one over, another 100. Very good. So, and now I knew I need to have something that holds the blade nice and secure. So this is why I have these keys here that will go into the empty element of the knife. But then so it doesn't wobble, it also needs further support. So for example, this is a little support surface, which I can extrude. Very good. And if I go further, it starts cutting in. I would like this to join. There we are. I can push this further through. That's good. Yeah, I have to be careful that it does not actually get through. And yeah, I have a continuous edge. So this is perfect. I could also select this and union, for example. Very good. Select then this face, and hopefully this will work by dragging it down. It did. Beautiful. You see, so easy. It's amazing actually how direct modeling here works. Okay, so let's take a look at all the elements here. So there you see basically how I added more material to the original object, so it has more kind of like material later I could work with to hold the knife. So now here's actually something I realized only afterwards. So when I have this object and I make a mirror there, very good. And then I would like this to simply rotate. The blade actually has to be not in, but under here. So two solutions to this. Either this side is thicker and this side is thinner, or I simply take the blade and move it 0.5 millimeter to the left. This is actually 0.5 millimeter thick, so not even 0.5 millimeter, just 1/4 millimeter. So let me show you what I'm talking about. So this we delete, and then this I would move over 0.25. So you see how it's nice and flush. And now I could actually select the blade and remove it. That's what I did there. You see how it created the cavity for the blade to go right into it. Okay. Because when I select this and put it on the other side, or essentially before I removed the knife, so this means this one here, I will make a copy to there. So you can see the steps I would use. Very good. Move this over 100 there. So there you can see how there's actually no material removed because this slides over the blade. And here the material is removed because this is where the blade has to sit in. And this 1/4 millimeter to the left or to the right really does not matter. Okay, very good. So last step really to do, besides adding the threading to the cap and the parts, is then also thicken this area, and then we can create a cavity for or a holding mechanism to put multiple blades in. The nice thing of this design is this cap we just screw off, and then you can rotate the two parts off, take a blade, put it in, close the two parts, put the cap back on, vice versa. So it's very simplistic and it just works. So how did I actually do those support elements? They first, let's say this is made out of plastic, will help making sure that when I really apply a lot of pressure on the outer surface, it does not collapse. And in addition, it actually will help holding the knives or the blades in place. So this we can hide, select this, bring this over another 100. There we are. Cool. So I just drew myself some very basic sketches, just boxes, 2 millimeter, very simple. Bring this in. I extrude everything together because now it's very easy to move to this view. Select this face. Basically that whole system, and then select this face and say replace. Next step, join them. Very good. And then we simply, again, move this over to close the shape. Oh, amazing. Just simple. I just wanted to say drag and drop. It's just so simplistic and it just works. And Shapr does all the rest for us. Oh, come on. There we are. Very good. Cool. If we do not want this to be perfectly flush, obviously then at this point, we want to lower this by a little bit or as desired, and then we would bring this back and sink it into the surface. But since I want blades actually to sit in there, each side needs to really be touching each other. Okay. This basically reaches the end of this exercise. If I move this one down, there you can see there is the threading inside the cap. There's the threading added to the lower part. And in here we have now all the blades there. The other part. Yeah. And if we move this up, there we are. So now we have a model of something that can be 3D printed out of plastic, 3D printed out of metal, could be prototyped, and then is probably ready to be also manufactured. I hope you enjoyed this journey of seeing all the individual steps and having this narration, how I used basic sketching and then Shapr's really amazing working direct modeling tools to create something actually quite complicated. And I hope that you saw if you break this down logically, it's actually pretty easy.